Here Chemistry Chapter 1. Blocks in the periodic table. Elements in the periodic table can also be classified into 4 blocks. This classification is based upon the valence orbital of the element involved in the chemical bonding. According to this classification, elements of first A and second A subgroups are called S block elements because of their various electrons are available in S orbital. The elements of third A and fourth A subgroups are known as P block elements as their valence electrons are present in P orbital. Similarly, in transition elements, electrons in d orbital are responsible for their valency. Hence, they are called d block elements. For lanthanides and actinides, valence electrons are present in f orbital. Hence, these elements are called f block elements. This classification is quite useful in understanding the chemistry of elements and predicting their properties, especially concepts of valency and oxidation state. Metals, non-metals and metalloids. Another basis for classifying the elements in the periodic table is their metallic character. Generally, the elements on the left side in the center and at the bottom of the periodic tables are metals, while non-metals are in the upper right corner of the table. Some elements, especially lower members of groups 3rd A, 4th A, and 5th A, have properties of both metals and as well as non-metals. These elements are called semi-metals or metalloids. In the periodic table, elements of group 6A and 7th A and 8th A at the top right hand corner above the steeped line are non-metals. The elements just under the steps such as selenium, strontium and titanium are metalloids. All the remaining elements except hydrogens are metals. The periodic trends in the physical property. As we have studied so far that in periodic table the elements are arranged in ascending order of their atomic numbers and their classification in the group and period is based on the similarity in their properties. Yet due to the gradual increase in the number of protons in the nucleus and electrons in the outer shell of the physical and chemical properties of the elements steadily vary within a group or a period. Here we study some trends in physical properties. Atomic size. Atomic radius. Atoms are so small that it is impossible to see an atom even with a powerful optical microscope. The size of a single atom therefore cannot be directly measured. However, techniques have been developed which can measure the distance between the center of two bonded atoms of any element. Half of the distance this distance is considered to be radius of the atom in the periodic table, and the atomic radius increases from top to bottom within the group due to increase in atomic number. This is because of the addition of an extra shell of electron in each period. In a period, however, as the atomic number increases from left to right, the atomic radius decreases. This gradual decrease in the radius due to increase in the positive charge in the nucleus. As the positive nuclear charge increases, the negatively charged electrons in the shell are pulled closer to the nucleus. Thus, the size of the outermost shell becomes gradually smaller. This effect is quite remarkable in the element of longer periods in which D and F subshells are involved. For example, the gradual reduction in the size of lanthanides is significant and called lanthanide contraction. Ionic radius. When a neutral atom loses one or more electron, it becomes a positive ion. The size of the atom is decreased in this process because of the two reasons. First, the removal of one or more electron from the neutral atom usually results in the loss of outermost shell, and second, the removal of electrons cause an imbalanced electron-proton ratio due to the greater attraction of the nuclear charge. The remaining electrons are drawn closer to the nucleus. Thus, the positive ion is always smaller than the neutral atom from which is derived. Thus, the radius of sodium is 157 picometer and the radius of sodium plus is 95 picometer. On the contrary, the negative ion is always bigger than its parent atom. The reason is the addition of one or more electron in the shell of a neutral atom enhances repulsion between the electrons, causing expansion of these shells. Thus, the radius of fluorine atom is 72 picometer and that of fluoride ion is 136 picometer. In a group of periodic table, the similar charged ions increase in size from the top to bottom.